Site visit is crucial for all design projects because you are dependent on certain inputs from sites in order to develop, finalize, and confirm your design. So it's necessary to understand what a site visit is all about and what are the inputs to be collected from site. Moreover, irrespective of whichever type of design projects that you're working, site visit inputs are really necessary in order to make certain decisions in the design. And moreover, the timing of the site visit will really help you to save the time. So in this video, let's try to understand what a site visit is about and what type of projects site visit is mandatory and what type of projects are exempted and why is it so important to do the site visit and what are the inputs needs to be collected from site. Without wasting your time, let's begin. Site visit is nothing but visiting the actual site condition. Visiting the actual site condition in order to observe, in order to collect, in order to take any references that will help you to develop or finalize and confirm your design. That is all about site visit. But it depends upon which type of project that you're going. So now let's explore what are the types of projects that requires a site visit. When we talk about site visit, it is not simply going to a site and coming back. You are visiting a site in order to see how you can develop your design, whether you have any constraints in the site, whether you have anything surprise that is observed in the site, because these are all things that will impact your design. After finalizing a design, if you find anything odd in the site, it will cause lots of manpower losses and you will have to revise the design and your commitments to the schedule has already been gone. So it is wise enough to understand at what stage you will have to conduct the site visit and what project. Only then it will fruitfully help you in order to complete your design. So let's understand what are the type of design projects that requires a site visit. Design projects such as brownfield, demolition, as-building, debottlenecking, revamping or any expansion project within the on-plot battery limit.
Sorry to interrupt you. Let's take few seconds to understand the importance of Pymedaca design courses. I will not say that Pymedaca courses are the best in the world, but I can strongly say that Pymedaca courses will help you to learn piping design skills. Unlike other courses where theories are predominantly focused, Pymedaca focuses on the job-related knowledge. The result is, you'll be able to perform exceptionally well in all piping design interviews and also in your job. There are 3 courses available in Pymedaca, primarily focusing on 3 primary piping design skills. One is P&ID, other one is pipe supports, and the third is pipe routing. These 3 skills are considered to be one of the primary piping design skills for any piping design engineering profession. You'll be able to find my contacts in the details of the course. You can contact me for any clarification regarding the courses.
So what are the projects that are exempted? Is the projects that has no connections with or from the existing plants or projects that are purely and 100% greenfield projects. So the process plans are being developed in a complete open land without any references from any of the neighboring associated plants or lines or facilities. So in that case, it is exempted because it's an open land. So you really don't have anything to visit. Now let's understand why is it so important to conduct a site visit. What happens if I don't conduct a site visit? Let me tell you a fair example to understand the importance of site visit. Imagine you received a project and you started developing your design without considering the site visit or without going for a site visit to collect an input. You developed a brilliant design which has gone for a design review, the client approved it, everything has been done. And now you are going to implement at the site. So you will have to remember whatever that you're going to build, you're not only going to build in the computers, not in the papers. You are going to build in the real site. You are going to build in the site where the other facilities also there. You are going to build in the place where there are lots of underground lines, lots of underground cables, existing lines or surprises will be there. Imagine the design that you have finalized with client and when you take it to the site and you found there are lines and facilities already placed in the place that you have planned your design. So now you will have to change the design. So fundamentally, if you don't check the site conditions and the money spent by the client has completely wasted and you will have to redo it right from the beginning. So that is why site visit is important. Site visit will give you lots of insight about the real-time site condition. So the example that I wanted to give you is, let's consider a line from where you wanted to take a tie-in and you have considered the informations which are available from 3D model and the 2D drawings. What if this particular line is not in a place exactly where it is shown in the 3D model in the real-time site condition. Your supporting has to be changed. Accordingly, civil foundations needs to be changed, relocated, and this will impact the underground cables, electrical cables, instrument cables, one after other. So the small impact in a particular tie-in will impact many other disciplines. And imagine that if this happens for multiple locations, so you will have to redo all your design right from the beginning. So these are the specific reasons why site visit is crucial. You will have to ensure that the site condition is matching with the 3D model or the 2D drawings where you're developing your design. If it is not matching, that is where you have to collect the input. So now let's see what are the inputs to be collected from site. The inputs to be collected from site is not limited only to what I'm going to say. It is about your entire observations from the first and foremost is you will have to ensure that the space available for your design, the space that you have studied for your design, is truly available at the site condition or not. If it is not available at the site condition, what is your option 2? And if the option 2 doesn't work, what is the option 3? Why I'm saying is that in site condition, you will find multiple projects parallelly going on, and there are underground lines which is not reflected in the 3D model or 2D drawings, underground cables which may not match with the actual drawings. You will find the cables in the 2D drawings and you will rely that information, but however it is not matching with the site condition. So based on which you must have chosen a support location, but in actual site condition the cables are exactly under where you have placed the supports. So the first one is the space identification for your design. The second most important is dimensional references. You will have to take the crucial dimensions that is required for your design development. For example, the location of tie-in, sizing of the tie-in, rating of the tie-in. Imagine the PFS shows 8 inch, but in actual site condition, it is 6 inch. If you have developed the design based on 8 inch, you must have ordered 8 inch T connections, 8 inch pipe elbows, but in actual site condition it is 6 inch. So this is the mismatch that you have to avoid. So you will have to take the dimensional errors. You will have to verify the dimensions, sizing, rating. So all this availability needs to be checked. And third important thing is that you will have to take as many photos and videos as possible, because human brain are not intend to remember everything that the human can see. So it's better that you collect as many photos as possible. And the fourth important is study. You will have to study. You will have to do your visualization in the site condition about your design. For that, before going to the site, you will have to do some site study preparation. Only then you can go and visualize in the site. If you don't visualize in the site, then you will not be able to understand the impact that it is actually going to make. For example, if you are planning a routing at certain elevations, you will have to visualize in the site. Only then you can realize whether it is hitting any other line or not. I will meet you in another fantastic video. Until then, bye from Subhash Chandra.